Hello friends, welcome back to our channel JE Multiverse. So today we are going to study conical pendulum. It is a very short and sweet topic, and questions asked are also easy. So let's first understand what is a conical pendulum. It is nothing but when we tie a fixed support like here, and from a string we suspend a weight or a bob, we can call it, and we whirl it in a horizontal circle like this. Okay, so string moves like here like this. In 3D, it is in 3D, imagine it in 3D. Then it moves like this and it moves like this. Okay, so the bob can be moving like this in a anti-clockwise motion, or it can be moving in a clockwise motion as well, but basically it is moving in a horizontal circle like this. Okay, so this is a conical pendulum, nothing else. And simple pendulum is like this, in a 1D 2D motion only, 2D plane only. This is in 3D, but this is in only like this, its motion is only like this. But this conical pendulum has a motion in 3D. Okay, understand this? Okay, this is nothing but conical pendulum. So I hope that you understand this conical pendulum. So in this conical pendulum we can apply some very basic mathematics. Okay, and we can calculate the speed of the bob. Okay, the speed of the bob, the tension in the string, etc., and time taken to move in a one circle, etc., etc. Okay, so let this be length L and this angle be theta with the vertical. Okay, so it will be moving in a horizontal circle like this. Okay, understood? Clear? And we only know L and theta and mass of the bob. We only know these three things: L, M, and mass of the bob and angle theta. Okay, we only know these three things, nothing else. So let this be moving, the bob be moving in a speed v tangential. Okay, so speed v tangential to the circle, we don't know what speed v is, and let the tension in the string be T, and mass of the bob is mg, so it will be exerting the force mg in downward direction. And this length here, let this be radius r of the circle in which it is moving. So when we draw the free body diagram of the bob, tension is acting in this direction, mg is acting in this direction. Obviously this angle will also be equal to theta because z is forming like here. Okay, understood? Perfect. So I'm just erasing this to avoid confusion. Okay, so this angle is here, we can write this angle is theta. So when we break the components of the tension, here upward direction it will be t cos theta, and in this direction it will be t sin theta. Obvious? And we can write that t cos theta is equal to mg because there is no acceleration whatsoever in vertical direction. So let this be equation number 1. And we can write that t sin theta is equal to, here the particle is moving in a horizontal circle. When we observe the top view, let's draw the top view first. In the top view, the bob is moving like this. Okay, in a circle v with velocity, in a circle of radius r with velocity v. Okay, so obviously centripetal force AC will be acting in this direction. So obviously t sin theta will be equal to how much? M into AC, that is equal to m v square by r. So let's this be equation number 2. Okay, so we have just balanced the forces in horizontal and vertical directions, nothing else. So see, so when we do equation, when we divide the equation 2 by 1, let's see what happens. So t and t will get cancelled here, so tan theta will remain, sin theta by cos theta, that is equal to tan theta, and v squared by rg will come. So v will be under root rg tan theta. Okay, but we also don't know r, but from trigonometry in this triangle we can find the relations between r and l. So we can write sin theta is equal to r by l. So are you understanding this triangle? I'm talking about this particular triangle. Okay, so sin theta is equal to r by l, and r will be equal to l sin theta. So we can substitute right here, and V will be equal to how much? Under root Lg sin theta tan theta. Alright, so this we have derived the expression for V, okay, by just knowing three things, L, M and theta. So we can also similarly derive the expression for tension. How can we do that? We need to eliminate first cos theta and sin theta. So we'll just do equation number 1 squared plus equation number 2 squared. So it will give us t squared cos squared theta plus t squared sin squared theta is equal to mg whole squared plus m v squared by r whole square. Alright, so when we take the t squared common, it will remain sin squared theta plus cos squared theta, which is equal to 1. Okay, which is equal to 1. So we don't need to worry about that. This will be m squared g squared plus m squared r power 2 and v power 4. Alright, and so t squared, it will be here like only t squared and m squared g squared plus now v power 4 we can write as how much? Lg sin theta tan theta raised to power 2 from here, from this equation, v power 4. Okay, and r square we can write as how much? R was L sin theta, so we can write it as L sin theta whole square, and obviously m square will come here. So as you can see here, L sin theta and L sin theta will get cancelled out. So what will remain? It as t squared is equal to m squared g squared plus here also m squared g squared, but an additional tan squared theta will come. Alright, so it will be t is equal to mg m squared g squared into 1 plus tan squared theta, that is equal to t is equal to how much? Mg under root 1 plus tan squared theta, that is equal to t is equal to mg, we can write it as sec theta. Okay, so it will be just t is equal to mg by cos theta. So we could have also derived it from here, this equation first also, but I just wanted to give you a hint that we can also derive it like this. Okay, there was absolutely no need for this. Okay, I just wanted to show you that if we do like this, the answer will also come. So now for the last variable, that is the time period. Time period is the time it takes to complete one circle. We can obviously write it 2 pi r by v. Okay, so 2 pi r v is under root rg tan theta, remember? So it will be like this, 2 pi under root r by g tan theta. We can also write it like this. Okay, and r, remember r was how much? L sin theta. Alright friends, so 2 pi under root L sin theta by g tan theta, we can write as sin theta by cos theta. So obviously sin theta is going to cancel, so time period will come as 2 pi under root L cos theta by g. Alright friends, so this was the formula of time period. You don't need to remember it, you can obviously derive it. Okay, and obviously there is no need for this big, I'm just going to erase it. There is absolutely no need for this whole part. Okay, and that's all. You just have to balance the forces in x and y direction, that's all, nothing else. And if you let me give an example. If you do like this example, if it is moving in angular velocity omega, okay, if it is moving in angular velocity omega like this or something, so when you break the components here, t cos theta and t sin theta here, and here it bound would be the mg. So here, remember carefully that t sin theta will be equal to m. Okay, m AC. So now AC we can write as omega squared r, because how much? V is equal to omega r, remember? So we can write it like this. And r, what will be the r? Don't take this length, no, r is this radius. Okay, so here we took the perpendicular radius. Okay, same here, of course we'll take the perpendicular radius here also. Okay, so let us do one more example here, this one. Okay, now this has two strings connected, so but don't worry, it is very easy question. So let's first read it. So a small block is connected to one end of two identical massless strings of length 16 2/3 centimeter each. Okay, and with the other ends fixed to a vertical rod. The ratio of tensions T1 by T2 is equal to 4:1. What will be the angular velocity omega of the block? So we have to do nothing else other than drawing the FBD of the bob. So wait, so assume that this is the bob and this angle was 60. Wait, yes, this angle was 60. Wait, I will just draw it. So let this tension string, let this T1 tension in the string be T1 and this be T2, right? And this angle was 60 degrees, so obviously this angle will be also 60 degree, and of course we have been given that these two lengths of string are equal, so obviously this angle will also be 60 degree and this angle will also be 60 degrees. Alright, now by drawing the FBD for free body diagram, what can we write? This direction we will be acting Ta1 cos 60, in this direction T2 cos 60, and mg will obviously come. Alright, and in this direction T1 sin 60 plus T2 sin 60. Alright friends, so this is the free body diagram. So we can all write that T1 cos 60 is equal to mg plus T2 cos 60, because there is no acceleration in vertical direction, and obviously we can write as T1 sin 60 plus T2 sin 60 is equal to m omega squared r. Okay, so now the question is, what will we take the r, radius r? So we can draw here like a radius r, and this is length L. So again we can write sin 60 is equal to is equal to r by L. Wait, I will just write it here. Sin 60 is equal to r by L. So r will be how much? L sin 60. Alright friends, we can substitute it here. L sin 60. So wait, I'm just substituting it here. It will be L sin 60. So all sin 60 here will cancel out because we will take them as common. Okay, so we are only left with these two equations. T1 cos 60 is equal to mg plus T2 cos 60, and other is T1 plus T2 is equal to m omega squared L. Okay, these two equations, equation number 1 and equation number 2, these two simple equations we can easily solve, and obviously it is given that T1 plus T2, T1 by T2 is equal to 4:1, and obviously third equation T1 upon T2 is equal to 4. So third equation is also given, and we check out the variables here, and so T1 is variable, T2 is variable, and omega is variable, and length L is given in the question, so it is not a variable. So these three variables are here, and we have also three equations, so we can easily solve these equations 1, 2 and 3. So after solving, I'm just writing the answer. You can solve it at home. This is the homework, kind of a homework for you. So after solving, omega will come how much? 14 radians per second. Okay friends, so I hope that you can understand the concept of conical pendulum. It is very easy, and we just have to balance the forces in x and y direction. And okay, so and nothing else. Time period, if you are asked to find, then we can write it as 2 pi r by v. Easy, very easy. And always remember to take a perpendicular radius, whether it is omega or it is given v in the question. Okay, so that's all for this video. If you like this video, please share this video, subscribe and like our and like this video and subscribe our channel. Meet you in the next video.